Welcome to Coding Advent of Code 2015, day 4. I've solved day 1, 2, 3, so today it is day 4. Let's just jump into it. So, text, do we want to read it? Find the MD5 hashes in which the hexadecimal start with at least 5 zeros. The input to the MD5 hash is some secret key, followed by a number and decimal. We are mining hash advent coins. I see, that's why we have hashes. So if our secret key is ABCD, then we will... Then we just append a number and take the hash value that has 5 zeros, and then that is the lowest number that does that. Okay, and this is our puzzle input. Okay, that's actually not much to this one. It's just doing it, I guess. Oh, not day 4, day 5. Oh my god. Day 4. Let's go into day 4 and copy the template to solve.py. Okay, so, and it's just make our test file. So input.in. Okay, so let's do it. First of all, we're going to read the file. So we're going to read the file, read it, data is equal to f.read, and then I'm going to strip the new line. And then we're going to need to import hashlib, because we're going to take the MD5 hash all the time. So I guess we're just running. Let's index equal to 1, and then while true, we're going to say that our key is equal to data plus our index, and then we're gonna compute the MD5 hash. I can't remember how to do that. Let's see. Import hashlib.md5 of. Can we just take it a string? Ooh, strings must be encoded. Okay, so that encode ASCII, I guess, would be fine. That gives me a hash object. What can I do with that? No one knows. Object dot hex digest. That's probably the thing I want to add. Yes, okay, that's what we're gonna do. Okay, so hashlib.md5 of our key, and we're gonna encode it using ASCII. Okay, and then we're gonna take the hex digest of this one. So let's just call it digest. Now we're gonna see it has 5 leading zeros. So if digest of the first 5 characters is equal to 0, 0, 0, 0, 0, then we're gonna break. And we are going to print key. No, we're actually gonna print the index. Let's just print both of them. And that's it. Solve the pie. Ooh. That's because I have to supply the input. Oh no. And I have to, oh my god, I can't even remember my own template. And I have to say that it's the first problem, oh my god, it's the first problem I want to solve. And it is running. Yes, and that's because I forgot to increment my index. So that was essentially just a infinite loop of always hashing my key plus 1. That's not gonna do anything. Oh boy. Okay, that was a value. We can actually, okay, let's check it with this one. So let's just make an test input. Alright, so Python 3 solved the first problem of the test input, and it should output 6 something 43. Alright, you know what? I think this is correct. I trust it. Let's just submit it. Yay, a golden star. Alright. 6 zeros. Okay, so this is gonna take 16 times as long as the first one. Let's just copy paste code, because why not? Oh, okay. Fuck it. We're gonna do it slightly prettier and then just say find leading zeros of key, which is a string, and the number of zeros, which is an integer, and then we're gonna return an integer. And we're just gonna do this. So our digest is gonna be the first, the number of zeros I'm interested in. And then it's gonna be that I want that to be equal to 0 times the number of zeros I'm interested in. And then I'm going to return the index. Okay. And then I guess if we want to do really pretty, we will print find leading zeros, data, and 5. And this one is just gonna be the same thing, but with a 6 instead of a 5. And I'm pretty sure this is gonna take 16 times as long. Okay, there's actually no really reason to do it on the test input. Let's just do it on the input. Oh no. Oh no. That is because my key is now called key and not called data. Oh no, now key is equal to key. I'm messing up. Okay, let's just call it input key. Okay, like that. And let's let it run. So the last time it took like, I don't know, 2 seconds, 3 seconds. So multiply that by 16. It's gonna be 30, 40, 50-ish seconds. So it's actually gonna be quite a while. Now, the question is actually a better way of doing it than just, oh, now it is done. And just brute forcing it. And the thing is, no, there isn't. At least, okay, maybe with the MD5 hash, because it's a fairly, yay, a golden star. The MD5 hash is like fairly simple. It has been broken before in the sense that we have found collisions. But if the problem had been asking about like the SHA-256 hash, yeah, there was absolutely no way of doing anything else but brute forcing. If you could do anything else but brute forcing, then I guess you could become extremely rich by mining all the Bitcoin in the world. Now, who wouldn't want that? Like, what is a block of Bitcoins worth? So I believe that you are getting 6.5 Bitcoins per block, and the Bitcoin price is, Danish kroner. Well, I don't know. Nobody has any relation to Danish kroner besides Danish people. So let's find United States dollarinos. This is also in Danish. It's going to be American dollar. Okay, $36,500. When I have loved to know that 10 years ago. Multiplied by 6.5. Okay, so 240,000 US dollars for every block mined of Bitcoin. Yeah, so if you can find a way to do anything else but brute forcing to find leading zeros of the SHA-256 hash, you're gonna be very rich. Yeah. Okay, let's go for day 5 because it was an easy problem. Okay, day 5. Doesn't he have intern else for this? Okay, blah blah blah. We're gonna find a nice string. So it contains at least 3 vowels. Blah blah blah. It contains at least 1 letter that appears twice in a row. And it does not contain the string A, B, C, D, P, Q, and X, Y. Okay, so this is our parcel input. It's a bunch of strings, and I guess I have to output how many nice strings. So a nice string, it has to satisfy these 3 criteria. Okay, so it's a matter of doing what the problem says. Alright, that one already exists. Let me just jump right into it. Copy the template. Solve the pie. Okay, and let me write the input. So the input, input.in. Okay, good enough. 1,000 strings. Okay, let's just make a test input as well. So that one, let's take that one. If I can do it, and that one, and that one, and that one. Okay, we have our test input. Let's do it. So with open path as file f data equal to f dot line dot split, no, not dot split, dot the split, can't remember, for line in f.read lines. So the thing is, I want no strip. That's the word I was looking for. Okay, I don't want the new lines. Okay, so for word in data, and then we're gonna find out if it is nice. So what was the criteria? At least 3 vowels. Okay, so let's count the vowels. 3 different vowels. Yes. Okay. So let's just have a vowel list. Vowels equals to, it is what, A, E, I, O, U, something like that. Yeah, that seems right. So has vowels. Okay, so if not, let's have a count of how many nice words there are. So if, okay, let's just say sum of C in vowels for C in words. Now we're gonna loop over all the characters in the word and check if it's if it is a vowel. We're gonna sum that up. So if that is greater than or equal to 3, no, let's do it the other ways. If it is less than 3, then we don't have 3 vowels, and the word is definitely not nice, so we can just continue. Okay, so that was the first criteria. Whoops, that's the first criteria. At least one letter that appears twice in a row. Okay, let's do it for that one. So we're gonna loop over the characters in enumerate data, and I don't want to look at the last character because the last character, if I have already reached the last character and I haven't found 2 in a row that match, well then there's not 2 in a row that matches. So I don't care about the last character. So if data of I plus 1, that is the next character, is equal to our current character C, then we has twice is false in the beginning, then has twice is gonna be true, and then we're just gonna break out because now we have found what we was looking for. So if you don't have twice, well then the word is certainly not nice, and we can just continue and forget about the word. Fuck that not nice word, and it does not contain the strings A, B, blah blah blah. Okay, so bad strings is oh my god, I hate this. Alright, okay, so those are the bad strings. So let me just see. Even if they are part of one of the other requirements. Okay. So for bad in bad strings, okay, let's say health bad is equal to 4. No, we can do this any. Yes, we can do some nice Python iterator thing. So any of bad in word for bad in bad strings. Doesn't that just roll off the tongue? Alright, so this is gonna be true if there is at least one bad word, bad string in the word. So if has bad, then we're also just gonna continue because then the word is not nice. At this point, the word is nice. Unbelievable, how great is that? We're gonna increment our count, and in the end, we are going to print our count. And let's just, for the sake of it now, let's print the nice words. Because I want to check on the test input if it is the correct set of words that we are labeling nice or not nice. Oh no. Blah 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 blah. It's not defined. How dare you, Python? Oh, that is because I didn't run my code and ran the test input. Okay, 0. Fuck. I did an oopsie. So what is the problem? None of them are good. Okay, let's print. Okay, so let's print the word, and let's print now vowels because we don't have the vowels. So let's print that. At this point, we're gonna print else twice, and at this point, we're gonna print else bad. Okay, and let's just. Before print a new line so we can distinguish things. Okay, so this one has twice. If not has twice, but you know what? It should have. Why doesn't it has twice? There's 2 D's right there. The double D's, man, why doesn't it? That is because I'm looping over data. Oh my god, big dum. We're gonna loop over the words instead. Ooh, and it is out of range. This should probably be a -2 and not a -1. You already... that is because the data should be the word. And was 2 correct? How many strings are nice? Nice, nice, naughty, naughty, naughty. Okay, so don't print all of these things. Let's just run it without all the logging. So yes, word 1 and word 2 are nice. Just for the sake, I'm a bit unsure if this -2 should be -1. So let me just, so if you have the string A, B, C, D, and I wanna, okay, yeah, -1 is the correct one. All right. Okay, now we're actually ready to do something. So solve solution 1 and input. Oh, I'm printing all of them. 278 nice words. Let's see, hopefully. God damn it. Okay. This is so sad. I don't want to do debugging. Oh no, oh no. Too high. So, for fuck's sake. Alright. Well, okay, so I might have found the answer. It is a case of read the problem. At least 3 vowels. A, E, I, O, U only. That means no Y. Look what I have here. I have a fucking Y. Okay. Always read the problem. Always read the problem. Okay, 236. This better be true. If it's not, I'm gonna cry. Oh, thank God. Okay, that was really important for me. Oh, I hate debugging shit like this. All right. Part 2. Realizing the error of his ways. Okay, so apparently we have a new properties. So word is nice if it contains a pair of any 2 letters that appear at least twice in the string without overlapping. Like XY, XY, or... Okay, so they are they. All right. So the AA appears there and they appear there and they don't overlap. AAA is not correct. So AA appears twice, but in an overlapping term. And it contains at least 1 letter which repeats with exactly 1 letter between them. X, Y, C, E, F, E, and even AAA. Okay, so those are the new properties. Okay, let's do this. I'm just gonna remove this debugging printing. Let me forget about not reading the problem statement. Hate reading problem statements. Okay, let's read the data. Okay, so the first one is any 2 letters that appear at least twice in the string without... Okay, so let's do that. So we're gonna loop for word and data. So the first one we're going to, let's just call it has twice, I believe. Yeah, let's just call it that. So let's loop over the characters and let's do over the indexes. So for IIDX in range length of word. Now I don't want to get to the last character because I want to look at the current character and the next one. So I don't want the last one. So now my 2 characters are gonna be word of index to index plus 2, I think. Yes. And now we're gonna loop over the rest of the word. So we're gonna start at index plus 2. We're gonna end at length of word -1. And we're gonna check our new 2 characters. We'll call it CD. So they're gonna start at index 2 to index 2 plus 2. And it's important that I start at index plus 2, otherwise I might get overlapping sequences, which I don't want. So if AB is equal to CD, then has twice is true, and I can just break. And I can also just break handle if has twice. See, this would be nice if I actually put it into a function, because then I don't have to break all the time. I can just return. So, I'm going to do that. Else twice. Else pair. Okay, let's just else pair. Let's just call it that. And we're going to have it a word. And we're just going to copy all this into our function. I don't need this variable because I just returned true. So in this case, I'm just going to return true. Kill that. I don't need to make this check. And if in the end I haven't returned, well, then it's because I haven't found a pair of words, a pair of characters that appear twice, so I can return false. Okay, so if not else pair, well, then it's definitely not a nice word. It's a very naughty word. And we can just break. No, continue. Because then we don't care about the word. Okay, and what was the next one? There was one letter repeats with exactly one letter between them. Okay, let's also just, for the sake of being nice, put it into a function. Else repeating word. So we're gonna loop over the word, length of the word, but I don't. Now I want to skip the last two because I need my current index, the next index, that's the middle, and the second next index, that is going to be the one I'm going to check against. So if word of index is equal to word of index plus 2, return true. Otherwise, if we haven't returned, then we have to return false because we haven't found what we were looking for. Okay, so if not, else repeating of word, then we're going to continue because the word is not nice. And let's just have a count. And then we're gonna say at this point, then both of my criteria are true and I can increment the count. I'm doing something stupid here, like that. Okay, I had some bad old code that I had to remove. Yeah, this looks good. Let's print the count. And my test input is not the same. Should we make a new test input? And let's copy this in. Doopy doopy doop. Oh, so you know what? Let's do some Vim macro things. So let's go to the end of the word. Let's remove the rest. And let's do that 3 times. Doop doop. Those are nice words. This one needs a Y because I messed up. Yeah, okay. Let's run it. Solution to test input 2. Is nice, is nice, is naughty, is naughty. Okay, and let's just make sure that it's the right ones I'm saying is nice. Yes, that looks correct. Okay, you know what? Let's do it. Let's do it. 51. Are you ready to see me get another golden star or cry in despair as I have to go back and debug my wrong code? No crying and no despairing for this time. Debugging can wait for day 6. Alright. That's it for this time, guys. Yeah, it took me some time solving problem 5 because I couldn't read the problem statement. So, yeah. Let's call it a day.